10.1, use properties of tangents. Circle. Okay, here's the formal definition of a circle. It is the set of all points that are equidistant from a given point. And this must be in a plane. So all that means is you have a given point. All these points around here make up a set, and this set of numbers is a circle. The center is the point which all the points of the circle are equidistant from. Okay, the radius, you should remember this, is from the center to an outside point. It's usually denoted with a little r. A chord, you may not know this one. A chord is a segment whose endpoints are on the circle, but it doesn't necessarily go through the middle. So this is a chord, and this is a chord. Technically, a diameter is also a chord, but we would be better off calling that a diameter, just like a square is actually a parallelogram, but we call it a square because that's a better term for that. Now, a diameter is a chord that contains the center. A secant is like a chord, except it's a line. It's not a line segment, and it intersects at 2 points. Okay, now a tangent is a line that intersects or touches the circle only at 1 point. So it barely touches it. Okay, example 1. Identify special segments and lines. So B to C. B to C is a segment. It goes through from the center out, and so that is a radius. Okay, line EA is this one. It's a line, so it goes on forever. It intersects at 2 points, so it is a secant. Ray D to E is a ray, touches the circle at point B, So it is a tangent. Okay, example 2. Use the diagram to find the given lengths. The radius of circle A. First, notice how the shorthand way to say circle A. We have a circle with a dot in it and an A. That means that A is the center of that circle. So A is the center of this little circle. Now to find how big it is, would we want to take a line from here to here? No, because that crosses across several squares. It'd be easier to count if we went straight across, down, or up, or sideways. So how many units are these? These are 2 square units. In reading our scale, our unit is only 1 a square, so this is 2. Now that makes our diameter twice this, or we can count and say it's 4. Okay, so the radius of B is 1, 2, 3, 4, and so its diameter is 8. Okay, checkpoint. Go ahead and do those 2 and start the video again when you're done. Okay, draw common tangents. A common tangent is a tangent that is to 2 or more circles. So we know we could draw a tangent on this top circle by going like this, but it wouldn't be a common tangent because it's not also common to the bottom circle. So let's just take that off. I don't know why it just moved it. So let's make that bigger again. Here we go. So let's draw common tangents. Where would our first common tangent be? Well, if we draw a line like this, it would touch both sides. If I also drew a line like this, it would touch both sides if my art was pretty good. Is there any more? Yes, there's one more. Can you see it? It is straight between these 2. So that gives us 3 common tangents. How about here? We have the same 2 tangents we started with on A, but do you notice that we don't have the middle one? Because if I drew a line through the middle, it would intersect at that point and this point. So tangents only have one intersection point. So that has 2 common tangents. How many can I draw here? Well, I can't draw a line like this because it would intersect here and here. So that would only be tangent to the small circle. So I just have 1. Okay, checkpoint. Figure out how much 3 has, and then look at 4. 4 has the same number as the problem number, which is 4. So see if you can figure out how to draw all 4 of those. Then start the video again when you're done. Okay, before I start on the next page, let's look at Theorem 10.1. In a plane, a line is tangent to a circle if and only if you can draw a radius from the tangent point to the center and it's perpendicular. And this helps us do a lot of fun math. Perpendicular. Because, can you see this would start making right triangles here? And we can do a lot with the Pythagorean theorem inside of here. So now let's go on to the next page. Okay, verify a tangent to the circle. In the diagram, chord RS is the radius of circle R. Is ST tangent to circle R? Well, we know that if all these numbers make the Pythagorean theorem true, then it is a right angle, and then therefore it is a tangent. Now, we are always verifying the tangent point as our right angle. So don't get confused when it may not look like it's a right angle. That's the one we're looking at. So we're going to put it in the converse of the Pythagorean theorem. So does 10 squared plus 24 squared equal 26 squared? And you will find that it does. So therefore, triangle RST is a right triangle. And RS is perpendicular to ST. So ST is perpendicular to the radius of circle R, and it's at its endpoint on R. So by theorem 10.1, it's a tangent. So checkpoint. Test the Pythagorean theorem with these two and see if it's right. And then start it again when you get through. Okay, find the radius of the circle. Now, we're told now that this is a tangent. So if we're told that it's a tangent, we can draw in the right angle right here. Okay, this 49 is a little bit confusing because up there we wrote the number for the whole thing, but this 49 is just for that spot. And we don't know what the radius of a circle is. So, what we're going to do is use the Pythagorean theorem again to figure out what the radius is. Now, this is slightly complicated math because we are going to write it this way. So, let's look at this equation right here. So, first, this is our short side, right here, right? Now, what is our longer side? The 77. So here's our Pythagorean theorem here. A squared plus b squared. Now they both equal the side across from the right angle, the hypotenuse. So what's the measure of that side? Well, it is r plus 49 squared. Now, it's very, very important that you don't say that r plus 49 squared equals r squared plus 49 squared. You can't just take this in. This is wrong. Because you should remember from Algebra 1 that r plus 49 squared is r plus 49 times itself, which means that we have to FOIL it. I know that some of you are really comfortable with foiling. If you're not, here's another way to think about it. We can put it in kind of like a biology Punnett square and say r plus 49 times r plus 49. And then we can multiply this out inside this square. R squared, 49r, 49r, and then 49 times 49 is 2,401. Then all we have to do is collect these two like terms to make that 98r, and then write it over here. Okay, this equals r squared plus 77 squared. 77 squared is 5929. Now I've got it set up so I can solve it. Notice that we have an r squared on both sides. So if I subtract r squared from both sides, it just drops out, doesn't it? So now I have 98r. Let's subtract the 2,401 to get me 3528. Then I'm going to divide by 98. And I get R is 36. Okay, so this is a little bit more complicated math than we've done yet this year. So you might take a minute and just kind of look over this again. Okay, theorem 10.2. Tangent segments from a common external point are congruent. That means if I have a point S here, and I draw a tangent to one side, and I draw a tangent to the other side, these two tangents are exactly the same. So this makes for easy math because, look here, example 6, we've got Q, this side 32, so what's that side? That side is also 32. That means that 32 must equal 3x plus 5. I can solve for x by subtracting by 5 and then dividing by 3 to get us 9. Okay, checkpoints. This is, checkpoint 7 is one of those harder problems. So, let me help you set it up. We've got short side is r, so a squared plus b squared equals c squared. So r squared plus, what's the medium side? 56 squared. And then what's the hypotenuse? It's the r plus 32 squared. And then come over here, do your Punnett square. Or use the FOIL method, whichever method works the best for you, and solve for r. On 8, that's a pretty easy problem. You can figure that one out by yourself.